example 2, just making sure we can graph by hand when it's not already in that nice transformation format. So at first you need to recognize that not everything comes in the format that we're looking at. In the quadratic, we can actually always rewrite it into that format. So if you love rewriting equations, which involves completing the square, according to 5th period, people's reactions were not so fond of completing the square. But if you really love it, you could always take any quadratic and then you can rewrite it into that vertex form where you can see like your A, your B, your H, your K, all that kind of stuff. But we should be able to graph it even if it's not in that form. So that's what we're going to look at right now. Okay. So when we look at this, here's our equation in standard form. I'm looking at example 2. I realize I'm doing them out of order. We're going to save the calculator for the end. So when I look at example 2, here's my equation. We should be able to recognize this is not in vertex form, right? It doesn't have that like nice little group where the x is contained in the square. It has an x squared term and a term with x and a constant. Okay. So what we're going to do is we're going to figure out how we can graph this. So remember yesterday how we kind of went through the overview of the different forms, okay? And we talked about how you would solve this, which is if it factors nicely, you could graph some solutions from there. If not, you could use the quadratic formula. But we remembered a small formula that came from averaging those two quadratic formula solutions, right? So this is going to be something we're going to want to remember. That small formula immediately gives us the axis of symmetry when our equation's in standard form. So what was that small formula? Yeah, Claire. Good. Negative b over 2a. So this calculation is going to immediately give me the axis of symmetry and where everything for this parabola is centered around. Okay? So just be really careful with your negatives and positives. A lot of you guys in your order of operation problem on your weekly reviews and then the one we put on the test, when you were plugging in for something and it had a negative in front of it and then the number was being squared, you guys knew when you squared the negative it would make a positive, and you knew a negative times a negative would make a positive, but you were like doing it all at once. If you squared something, it became positive, but then it was being multiplied by a negative, it would actually become negative again. So just be really careful with your signs. I think we're going really fast sometimes, and we're not paying such close attention. So this is the negative from the formula, and then the b value is actually negative 16 from the equation. And I want to divide that by 2 times a, which is 2 times positive 4. So this will be positive 16 over positive 8, which turns out to be 2. Okay? So this tells me everything in this parabola graphically is centered around this axis of symmetry at 2. So if it helps you, you can mark that on the graph. So this is the axis of symmetry. X is equal to 2. Okay, so our axis of symmetry, just next to it here, that X is 2. How does that help me get the vertex point that I need to know when I graph the quadratic? Yeah. Good, we plug it back in. So we have an X value of 2. We know the vertex has to be on that line, okay? So we're looking for our vertex. We know the X value is 2. For the y coordinate that goes with that. And anytime we have an x and we're trying to figure out a y, just plug it back into our equation. So if we plug 2 into this equation as x, we should be able to follow basic order of operations and get y. So 2 squared is 4 times 4 is 16. Okay. So we would have y equals 16. And then 16 times 2 is 32. That's negative 16 plus 10. So that's going to give us negative 6. Okay, so 2, negative 6. Point. Okay. Now, how am I going to get some other points for this? So we talked yesterday about solutions are nice, but are they always nice? Like, do you want to have to plot that negative 3 plus 3 rad 10 over 2, like we found as the X-intercept for our last one? I don't think that's the most convenient point to plot, right? So we don't have to plot those points. If they're super convenient, something's jumping out at you, go for it. But that does not have to be where you go to when you're graphing. If we ask you for a solution or X-intercepts, you need to be able to go find those. But if you're just graphing and those aren't super convenient, you should be able to get other points. So how can we get some other points? How can you get points for any function that anyone lays in front of you? Yeah, Zen? Okay, so option 1 in this case, if you're not too far away from the y-axis, you could work on finding the y-intercept, okay? Because plugging 0 into this is really, really nice because of where the x's are. So if you're finding a y-intercept by plugging 0 in for x, this just becomes 0, this just becomes 0, and you're left with 10. So we know that 0, 10 is our y-intercept, so we can plot that. And then we can plot the point that corresponds to that because of the symmetry of the parabola on the other side. And this would give us a good idea. What if you weren't close to the y-axis? So like this was even cutting it close, right? If we were a little bit further away, our y-intercept would have been so high that it would have been difficult for us to plot on the graph that we have provided here. So what else could you have done besides specifically choosing the y-intercept? When you first learned how to graph lines in Algebra 1, most of your teachers have you do what? They give you an equation, and what do? Yeah, you get points, right? How do you get points for anything that you're trying to graph? So this is like a key thing just to help you guys out in the future. If you're trying to graph anything, we have all these ways for you to do it and stuff like that. But if you get some basics and you're just missing some points, remember you can plug in an x at any time and get a y. There's nothing that's anti that. We just have some ways to do some other things faster. So if you were far away from the y-axis, you could have plugged in any other x value and got the y that went with it. Okay? So like if I plugged in 1, okay, I would get negative 12 plus 10, so I'd get negative 2. Sorry, that's not the point 1, negative 2. To that. Okay? So then we have our parabola. You were probably good enough just by getting the y-intercept and the point that went with it. I just wanted you guys to be aware in case the y-intercept is not something convenient to graph that you could just plug in anything that you wanted. Okay? Once you have this, should you be able to answer that same chart of values the same chart of characteristics that we've been answering about the ones that we graphed by transformations? Yeah. You have your vertex point. You should be able to label increasing, decreasing intervals. We're going to give you more strategies and go back through your solving techniques from Algebra 1 to find X-intercepts. But all of those things you should be able to label no matter which way we graphed them. Okay? So graphing these ones by hand, we just really want to start with this right here to give us where it's kind of centered and located. We have to understand how that's related to the vertex and then how to get some other points. Okay? Any questions about that? Okay, so now what we're going to do is we're going to go up and do the first example. We're going to put that equation, y equals negative x squared plus 6x plus 3, into our graphing calculator. And I'm just going to show you a couple of ways, like the power that your graphing calculator has, how it's been programmed to help you just find maybe intercepts or the minimum or maximum point as a tool. Okay? So, is it okay if I take this off the screen? Does anybody need this? All right, so let's go ahead and type this equation into our graphing calculator. So if you guys remember how to do this, our y equals is the button that's going to let us type in an equation to graph. I'm going to go to y equals. It should give us a list. If stuff is in there that you don't want to see, remember you can clear out equations. I don't need any of these, so I'm going to clear them out. If up at the top you see like mine, see how plot 1 has it's like bold around it? That means it's turned on. If you want to turn it off, but you don't want to go back through the stat plot stuff, you can just move your cursor up on top of it and press enter, and then it's no longer on, and it won't go trying to plot those points anymore, okay? So I cleared everything out. I don't need any of it, and I just want to focus on this, and then I'm going to type in our equation. One big thing when you're typing in the equation, it was negative x squared. In this calculator, the minus is subtraction, and if you want a negative, it's this button here. So if you type this, it's not going to understand what you want it to do. It's going to be expecting something to come before it to subtract. But if you type this, it will know. So I'm going to click the negative button. and then I'm going to hit the X, this variable button up here next to the green button, okay? That's where you can immediately just get your X. If you use the letter X key, it might think you're talking about a number that you've stored in there sometimes, so just be aware of that. And then the squared button is right here, okay, next to the comma. And then it's plus 6x, and then plus 3. Now, before I go graph, I don't know what my window looked like, and I don't know a good window, actually, because I haven't thought much about this equation. So I'm actually just wanted to zoom back to the, like, 10 by 10 by 10, like, in every direction. So before we go hit graph, let's hit the zoom button. So right here, top center. And let's choose choice 6, zoom standard. And that's just going to do like positive 10, negative 10 in each direction on each axis. Let's see if we can see our parabola. Okay. There's our parabola. Not bad, but I want to be able to see the vertex point. So how should I change my window in order to be able to see the vertex? Where do I need to see more of? Up, right? So let's go hit window. If I want to see more up, I need to change the Y maximum to something bigger than 10. I'm just going to put 20 right now because maybe I don't know. And then I'm going to hit graph. Okay, now I can see it. Okay. I set 20. It doesn't really matter if you have some better idea. I didn't calculate the vertex, so I was just trying to make sure I could see it. So I set it to 20. So I changed the Y max. So the next thing that we're going to do is we actually want to use our calculator as a tool to find some stuff, okay? So we're going to go through and we're going to actually figure out how to calculate X. See the trace button right here? Don't push it. It just lets you trace your graph. I mean, it doesn't matter if you did push it, but right above it, there's a blue word that says calculate. Anytime you're trying to calculate something off of the graph, that's where you want to go. So we want the calculator to calculate our vertex from the picture. So we're going to go second, trace, which gives us this calculate menu. Excuse me. And then it's asking us what we want to calculate. A value, a zero, a minimum, a maximum, an intersection, and then some like crazy calculus stuff. So if we want to get our vertex for this kind of parabola that's facing down, which one of those things 1 through 5 do we think we're trying to calculate? Maximum. So we choose maximum. So I choose choice 4. And then my calculator is going to ask me 2 things. So the first question it asks me is left bound. It's literally just telling me, can you please go mark something on your graph that's to the left side of the vertex that you want me to calculate? So you can scroll to anywhere you want. Where we are would be fine. You can go like this. But you just have to be on the left side of the vertex. You press enter. The calculator makes a little note for itself of where that is. And then it changed the question to say right bound. Now it's saying, will you please scroll somewhere to the right of the vertex? Okay, so just keep pushing the right arrow till you're on the right side so that I can calculate the vertex. So it's doing a calculus calculation where it needs just kind of some boundaries. And then it says guess. You can just press enter, or you can put your cursor somewhere near where you think it is and press enter. And it does this little calculus operation, and then it tells you what it is. So this says 3.000000011 or whatever. It's probably 3. Again, your calculator is doing a calculus operation to figure that out. So there is a little small margin of error. So you might see the zeros like that sometimes. So our vertex is at the point 3, 12. Is that okay with everyone? Yeah, then. Yeah, that's okay. Again, there's a margin of error, and it's using a calculus operation. So it's taking the 2 things you gave them and is doing this thing over and over and over and over again to determine that this had to be the place where the graph turned around. So there's a small margin of error, but both of those things would basically be 3 the way that they're written. Yeah, if there's a lot of 9s or a lot of 0s, you can round. If there's not a lot of them, you're right. It's just a different number, like it's like 2.9. But when it's like 2.99999 and I have 3.0000000, then like it's 3, okay? Because again, it's doing like a procedure. It's not just looking at the graph and knowing where it would plot, okay? All right, and then the other thing I want to show you is that it can also calculate your intercepts for you. It can calculate your X-intercepts. So you have to do them. If there's 2 X-intercepts, you would have to do the process twice to get each intercept. You can only find one at a time. And again, the calculator does a calculus type of thing, so you have to give it some boundaries, and it does this process over and over and over and over again till it like gets to a point where like, oh, that's past it. Oh, that's past it. It had to be this thing in between here. And that's kind of how it's getting an approximation. So let's work on finding this one on this side. Okay, that's our focus right now, to find the X-intercept that's over here. And so we're going to go to the calculate menu again. Okay, so second and the trace button. This time, what do you guys think we're calculating? Okay, so it's a little confusing. I would think intersect 2 at first, but we're not finding an intersection, we're finding an intercept, and those are 2 different things. An intersection is 2 things that you've graphed and where they're hitting each other, like if you wanted to solve a system. So it's not going to be intersect. What other word up there is the same thing as finding an X-intercept? A 0. Remember, solutions, roots, zeros, X-intercepts. So we're really finding a 0 of the function, so we choose choice 2. Okay, so again, it's going to ask us the same question. So please understand this. This is the 0. Along the curve this way is all stuff to the left of the 0, correct? Because even though it's above it, because you have to be on the curve, those points are coming from x's that would be to the left of the 0. Anything down here in this case is to the right. But if we were doing this 0, the stuff down below it is to the left, and the stuff above it is to the right. If you're unsure, put your cursor as close to the 0 as possible, and when it says left, click the left arrow a couple times, and when it says right, put it back on the 0 and click the right a couple times so you know you're to the left or to the right. So right now it's saying left bound, so I'm going to go towards that 0 and click something that's not on the 0 but would be considered to the left of it. So if I think that's the 0, I'll click the left arrow, that's to the left. Then it asks the same question again, just like when we were doing the other stuff. Where's the right of it? If you're not sure, put it back on the closest thing you can get to the 0 and hit your right arrow a couple times. Think that's to the right of it. Then it says guess, so just kind of sit close to your 0 and press enter. And so 6.46, comma 0. Did anybody get something besides 0 as the y coordinate when they just did their 0 calculation? Yeah, what'd you get, Catherine? So 2e negative 12 in calculator speak is 2 times 10 to the negative 12th power. And so that is 0.11 zeros and then a 2. So again, if there's lots of zeros or lots of 9s after that, we're going to round it to that nearest thing. But I'm not going to round 6.46 and think that they meant 6. Like, no, that's clearly not like 6.9999999 or 6.000000. But the ones that are like that, remember, the calculator's doing something that you haven't learned, but you will learn in calculus to be able to do this. And so there are some approximate values that it's getting there, but you can tell the ones that are zeros or should be rounded up by the number of zeros or 9s they have after the decimal. Okay? Is this all right for everybody as far as what your calculator can do?